In this video, we're going to focus on reference angles in degrees. Before we go into this notes that we have right here, let's have a review on the basics of the unit circle. Please remember these basic information about the unit circle. First, the center of the unit circle is located at the point of origin or at 0, 0. This implies that this unit circle is part of the x and y axis. Another information that we need to remember about the unit circle is that the radius of the unit circle is 1 unit. Radius is the distance from the center of the circle to the side of the circle. So that means the distance from here all the way to this point right here is 1 unit. So I can go ahead and label this as 1, and that is true for all the rest of these parts, which means that the lengths of all of these line segments from the center to the circle is 1 unit. Now, another thing that we need to remember about the unit circle is that the unit circle is divided into 4 quadrants. So this side right here will be our first quadrant. This part right here is our second quadrant, and this will be the third quadrant right here. And this part right here is the fourth quadrant. Now, another thing to remember is that one full cycle of a unit circle and all other circles will be 360, which means that if we start from the 0 right here, if I turn this pencil around the center of the circle, one full cycle would be 360. Okay, going back here, reference angles are defined as the angles in the first quadrant. So these are the angles that are located on the first quadrant. So these angles right here. It is very important that we know the reference angle. It's because once we know the sine, cosine, and tangent values of these reference angles that we have here, we would be able to determine the absolute value of the sine, cosine, and tangent for all the rest of the angles around the unit circle. In this picture, we can see that 150, 210, 330, the reference angle is 30. Now, if we have 135, 225, and 315, the reference angle is 45. And if we have 120, 240, 300, the reference angle is 60. How do we determine the reference angle if the unit circle is not drawn for us? This is where these 3 formulas would come in. So these formulas that we have here would only work for one cycle only. One cycle only means one full turn around the circle. So we're going to use this formula that we have here in this example. So let's take these examples right here. Determine the reference angles of the following. So first we have 120. So in order that we can determine how this works, we're going to draw the x and y axis first so that we would know where is this 120 located at. So this is how it's going to look like. So first, this is 0, this is 90, this is 180, this is 270, and this is 360. It says that, and these are all in degrees. It says that it's at 120, so that's 90. So 120 should be somewhere around here. So it should pass 90. So this is the 120 degrees. So this is approximately 120 degrees. And we remember that this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Since we see that this 120 angle is located on the second quadrant, we're going to use the formula for the second quadrant, which is this one right here. So this is the formula that we're going to use. So I'm going to write the formula up here. This means that reference angle for second quadrant is equal to 180 minus the angle that is located in the second quadrant. So that's how I wrote 2 here, because that's on the second quadrant. So we're gonna plug it in. So that's gonna be 180 minus the angle that we have is 120. That's on the second quadrant. So minus 120. So which means that our reference angle here is 180 minus 120 is 60 degrees. So this is our reference angle. At this time, I would encourage you to pause this video and try these two problems out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, I'm going to set up the x and y axis here so that we can locate where the angle is located. Okay, so 210 is this is so we're gonna draw 210. So this is 180 and this is 270, so it should be sitting somewhere around here. So I'm just gonna approximate it that it's located somewhere here. Then I'm gonna draw the angle right here. This is 210 degrees. So then this is located on the third quadrant. So then I'm going to use the formula for the third quadrant. I'm just gonna write it down here. Okay, so I used the formula for third quadrant. That's gonna be the angle on the third quadrant minus 180, so that is a 210. So 210 is located on the third quadrant. So 210 minus 180, that would come out 30. So the reference angle for 210 is 30. Did you get the same answers as this? Good, perfect. Now let's move on to 315. So I'm gonna draw the x and y axis right here. Okay, so the reference angle for 315 is 45 degrees. Did you get the same answers as this? Good, perfect. Now let's move on to the next example right here. So suppose we have 100 degrees. What is the reference angle for this? So it's pretty much the same thing. We are going to draw the x and y axis. Okay, since this is located on the second quadrant, so then I'm going to use the formula in determining for the reference angle on the angles that are located on the second quadrant. So then I'm just going to go ahead and show the work down here. Okay, so the reference angle for 100 degrees is 80. At this time, I would encourage you to pause this video and try these two problems out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. I'm just going to show the work up here. Okay, so the reference angle for 308 is 52. Did you get the same answer as this? Good, perfect. Again, please remember that it is very important that we label the quadrant so we know which of the formulas we are going to use in order to determine the reference angle. And then again, these are the formulas to determine the reference angles. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!